Hello and welcome to Banks and Markets. This is Binam with a quick illustration on Monte Carlo Simulation method. If you need the PowerPoint slides and the data file that I will be showing you in this video, just click Finance and you'll get it there. The PowerPoint slides I have already opened, which is this. So what we want to achieve today is using Monte Carlo simulation, we want to see what will happen to, let's say, S&P 500 index performance next month. So for that, obviously, we want to see and find out what is the nature of S&P 500 monthly return. Given S&P 500 is such a uh, popular index, you can simply type S&P 500 monthly returns and you'll get some information, something I've just checked. So you can click here, and then this website is giving you information that S&P 500 monthly return as of September in 2020 was negative 3.92%. Over here on the right hand side, you can see some analysis is here, and it is saying this is lower than the long-term average of 0.46%. So let's see if we can achieve something similar, for which we now need to download the data. And Yahoo Finance is something we can use this platform to obtain, download the data for S&P 500, and that's what I'm doing here. And I can see the S&P 500 information is here. I can click historical data and define the data length, the time period that I would like to incorporate, after which I can download the data. So let's say that I want to download the data from January 2000 all the way now. So I have defined the data period, historical prices. Now it is daily by default. Let's change it to monthly because here it is all monthly as well. So I've defined monthly. Now I just need to click apply, and then I will download the data. The downloaded data is here. I just need to open it, and now this is a spreadsheet that I can see, which basically means I have the data that I needed in order to apply the Monte Carlo simulation method. So that is what we obtain. And what I will do, just in case you want to play, you want to use the same data for your practice, I will call it raw, so I will leave it as it is, and I will make a copy of this, and I'll work on this new worksheet, which I will call Monte Carlo simulation. These are valuable information for my Monte Carlo simulation analysis. So what I will do, I will delete those that I don't need, and over here now I can find out my monthly return simply by dividing the new index value by old index value, take away 1. So that's what I obtain. I will double click, and I will also change the format into percentage and 2 decimal places, because then this is similar to what I have here, 2 decimal places, percentage. And for September 2020 it is saying 3.92% negative. Let me go down to find out September 2020, which is this, and that's 3.92%. so that's something I have found, so that's fine. And I have deleted the other 2 monthly figures, so now I have this. So what I would like to do now is find out the average return, because in this website it is saying the long-term average is 0.46%. So let me see what is the average monthly return for S&P 500. So I can simply do equal average and highlight the array all the range, so I get this. So it is giving me 0.45%, not 0.46%. Let me see if I can change this. Let me delete the February 2000 return. Oh yes, so when I deleted February 2000, it is exactly similar to the one given by this website. So I have found it, but let me tell you, it could be totally a coincidence that this is matching the value here. The website here may have taken a completely different time period, so that's something I cannot guarantee, but nevertheless I have same value here, which means I can now proceed. What I will do now is I will compute the standard deviation of the monthly return, and therefore I can simply copy this, paste it here, and change this to stdvs, which is sample standard deviation, which is 4.35%. So what I would like to do next is I want to simulate the 12 months S&P 500 return. So for which what I will do, I will type Jan, I will type Feb, and I will type March, January, February, March, and then I will scroll it down so that I go all the way to December, and therefore I have defined all 12 months. So what I want to do now is find out the simulated returns for different months. So if I am going to apply the Monte Carlo simulation method, then I can use the randomly generated values. So that is a key concept and also the foundation of Monte Carlo simulation method, that the number is generated randomly, similar to playing a roulette in casino. You don't know where the ball will land, any number can be taken. Similarly, if you use the function equal rand open bracket close bracket, it will give you a value between 0 and 1, but it can be any number. So what we can therefore do now is we can apply some kind of distribution function here. So what I will do is apply num inv. So normality distribution assumption is there, and where it is probability, I will say randomly generated, that will take any value between 0 and 1. And for the mean, if it was a standard normal distribution, you know it would be 0 for mean and 1 for standard deviation. But here I will just take these values, because these values here represent the characteristics of S&P 500 return. So that's what I have done, and I've also locked these two values so that I can now copy and paste these for all my 12 months. So that's what I have obtained. Now if I wanted to find them in terms of cumulative, then what I need to do is simply multiply, find the product of 1 plus each return. So what I can therefore do is 1 times 1 plus the return for January, and that's what I will get. And this can now multiply 1 plus the February, such as this, so that I can obtain the cumulative return. And the last thing I need to do is just take away 1 from here. That's what I have as cumulative return. Now it's up to you if you want to apply this or the value. If you think value can help you understand easily, you can change 1 into 100, and then the cumulative will simply be, you can just take this value here. So for clarity, I will just copy this down, and I'll put a color here so that it's distinct. So what you have done here is simply generated the output from your input, which was 100, and this is your output, and this output has been generated using the simulation for which you applied some kind of distribution here using norm INV. Probability is your randomly generated number, and then the mean and the volatility given by S&P 500 monthly returns. Now what you can do is you can copy this and paste it here. So what you have done this time is you have generated the outcome here again, but this can be treated as your second simulation trial. So therefore what you can do is you can say add 1, so that's your second, and therefore you received this number here. Now what you can do in fact is you can copy this across, therefore you can have a large number of them. So your third simulation trial will come here, fourth, 5, 6, 7, 8, and so on. So you can see I have just very quickly ran 14 different simulation trials, and therefore I have 14 different outcomes here. So we have achieved a large 15 different simulation trial generated outcomes. So what we know about Monte Carlo simulation is we need to have a large number of experiments. A large number of experiments is important, as you see here. So in order to achieve this, what you can do is copy similar to the one I have just shown you and continue to drag it all the way possible until the end, because a very large number of simulation trial is important. But then it is very time consuming, space consuming, and you may like to put these values one after another, whereas there is a gap. So in order to achieve the simulation generated trial generated numbers, what you can alternatively do is apply the function available inside the data tab, which I will show you in a second. But first you need to define how many numbers of simulated trials you want to achieve. Now let's assume that we want to achieve 3000 simulation trials. So what we can do is we can start from 1, and therefore that will be 2 and 3 and so on. Again, what we are trying to achieve is first simulation trial we obtain this value, second simulation trial we obtain this, and the third we have this. But we don't want to stop here, we want to take it all the way to 3000. So where will 3000 end? So this is E19, as you can see, the cell reference. If you want to go all the way to 3000, what you're saying there is you want to go all the way to cell reference 3018, which is somewhere here. So now what you can do is copy and paste it all the way down. There is nothing difficult here. You've simply done the numbering from 1 all the way to 3000. So once you achieve that, what you can do next is highlight all of these, both the numbering and the cell in this column where you want the values of repeated simulation trial to appear. Once you achieve this, once you have highlighted this, what you can do now is go to data, click what if analysis, go to data table, do not do anything here, column input cell, go here and find out an empty cell such as this, where there should be no value. Remember again, this is just a way around to achieve a large number of simulation trial, and therefore we are doing this, and now just click OK. So you see you have now achieved all these different values. From these values now you can approximate and find out the answer related to your next month S&P 500 cumulative return. Okay, so let's say that you want to find out first what is the average. So what is the average? Average will be all of these. So that's for 3000. So you have obtained the average, which is 105.2572. Now let us assume that you want to find out um, the probability that the S&P 500 return next month will be, let's say, greater than this monthly average. So that's 105. That basically means it is the investment amount was 100, so you want next month it to be more than 105. So probably that S&P 500 next month will be, let's say, greater than 105. What is the probability? So what you can simply do is you can do equal count if the range, which is all this, and then define the criteria. Again, that's simple. You just need to say and define that criteria, which is this is going to be greater than 105, and inverted comma close bracket. This will then give you the number of simulation trial given values which are greater than 105, which is this number here, 1490 of them. But you need to find the probability, so percentage of them which will be greater than 105. So therefore you divide it by 3000, and then you can just change it into percentage if you want to. So therefore you have 48% of the time the S&P 500 return next month will be greater than 105. So that's what you have been able to obtain. Now you may want to do something else, such as what is the probability that the S&P 500 return next month will be, let's say, greater than the one given by historical average return. So what is the historical average return? Okay, probably that S&P 500 return next cumulative, let's write cumulative return next month will be greater than the one given by historical average return. So what you are saying here basically is your investment amount was 100 times your actual historical average is 0.46%, so you will therefore get 100.46. So this then basically means you should have a lot higher than this 49.83. So here what you can now do is just copy this, paste it here, and then what you can do is simply change this to 100.46, and that is the number you will get, and that is the answer. In percentage you simply need to change the formatting, which is what I have done. So this is close to 60% is what you found. Not only this, you can also apply a number of conditions, such as the last example, I can say what is the probability that the cumulative return will be next month will be, let's say, equal to or greater than, let's say, 110. So that's basically the cumulative return you're trying to find out is more than 10%. So therefore what you can do, type in 110 here, and then over here what you can do is copy this and paste it here. You see the computer gets slower because each time I hit enter or move my cursor, it is changing the values. So what you need to do is equal to or greater than 110, and that's what you get. So this will be lower. Yeah, so this will be, or you need to put equal to or greater than, such as this, and therefore you get the value which is 37% and 13%. Okay, so that was a quick illustration on the use of Monte Carlo simulation method. In my next video, I'll be showing you the application of Monte Carlo simulation to calculate value at risk. So thank you very much for taking out your time to watch and listen my video. Thank you.